Hello, ladies and gentlemen of Earth Science 1. I just wanted to spend a little time with you. I hope everything's going well for you and you're doing fine. Just wanted to talk about Chapter 18 a little bit. The winds of the world, the Earth's major weather systems. I teach meteorology at Wayland Baptist University. And in this course, there's just one chapter that talks about it. But by the end of this chapter, you should be able to... I'm sorry, excuse me, about to sneeze. Excuse me. You'll be able to explain why our planet's atmosphere constantly flows on a global scale, discuss why tropical rainforests and subtropical deserts develop where they do, recognize the effects of monsoons and the ENSO events, and explain why these meteorological phenomena are so important to society. Illustrate how forces acting in the atmosphere generate hurricanes. Explain how mid-latitude cyclones develop and affect weather. And then finally, describe the relationship between weather, fronts, and jet streams. Some things to think about. I'm gonna pose a question to you, but also answer the question since this is just a one-way conversation here. The summer-winter transition, the summer to winter transition in the weather in the American Southwest and northwestern Mexico has been described as a North American monsoon. Based on your understanding, studying the book, and maybe some outside reading that you've done of monsoons, can you, or maybe some of your own experiences in monsoons, can you propose reasons why meteorologists might use this terminology? Well, my answer would be this. A monsoon refers to a seasonal change in wind direction or air circulation. Meteorologists refer to the transition from summer to winter as the North American monsoon due to the change in wind direction that occurs during this time. In the summers, the sun heats the deserts. All the deserts in the southwestern United States and the northwestern part of Mexico, while the waters of the eastern Pacific remain relatively cool. The air over the land develops a lower pressure as it warms, and moist winds from the Pacific blow eastward over the deserts. And this is a typical summer for wind patterns in monsoon regions. Also, the rains that fall during this time yield nearly 70% of the region's rainfall, another characteristic of monsoon regions. Let me ask you another question. Airplanes. Here's a scenario. Flying from Seattle on the west coast of the United States to Boston on the east coast take about 5 hours to make the trip in winter. When they return to Seattle, they take about 7 hours. So why is that? Explain why the times are so different. Will the difference change with the season? Okay, well, here's my answer. Flights across the United States are impacted by the winds of the polar front jet stream. We call it the jet stream, which is at the same altitude as typical flight paths. You know, when they say, ladies and gentlemen, we're now cruising at an altitude of 30,000 feet. So the eastward flight from Seattle to Boston will be quicker due to the tailwind provided by the eastward flowing jet stream. However, a westward flight from Boston to Seattle will take longer since the plane has got to fly against the jet stream, slowing the speed of the airplane. Differences will occur depending on the season due to seasonal changes in the position of the jet stream. The jet stream shifts north to northern Canada in the summer and south to the middle. Man, I'm about to sneeze again. And south to the middle of the United States in the winter, so its effects on Seattle Boston flights will be weaker in the summer. How about this one? One more that I wrote down. Outside it's cool and rainy, and the wind is from the east. 2 hours later, the rain has ended, the temperature has increased, and the air now feels humid. Yuck. The wind is from the south. What type of front passed your location? Anybody want to raise your hand? Take a stab at it? Well, let's see. Warm air is replacing colder air, so a warm front has probably passed your location. A warm front is located where a cold air mass retreats and a warm air mass advances. At a warm front, the warm air flows toward and then over the cold air mass. And at your location, the lifted air contained enough moisture to produce rain. And the rain is not impressive. It just turns out to be dry and humid. So there's some things in monsoons and this global hydrological water cycle that are very special. Some special cases that NASA produced. You could go on NASA and study Hurricane Katrina, for example, hot towers regarding Hurricane Katrina. You could also track a superstorm that NASA provides. There's some links in your book to that. You can also learn about El Nino and La Nina. The National Oceanographic and Atmospheric Administration, or NOAA, has a good article on that to recognize explain how sea surface temperature changes in the Pacific Drive, the El Ninos and the La Nina events, and also NOAA discusses some of the societal consequences of these events. It's all about the effects of monsoons and the ENSO events. So you could go to that video. I'm not gonna show it to you through Canvas, but you could check that video out. And there's some other things that the authors show you. Special notes about CASA radar tracking tornadoes up to the minute. And that's literally what's going on, and that's in Science Nation. The National Science Foundation has a pretty good video on that. It describes how scientists at the Center for Collaboration Adaptive Sensing of the Atmosphere, CASA, use new, more closely spaced radar systems to more accurately track tornadoes. That's pretty cool. I'd rather watch that movie than actually model a tornado because that requires Calculus 3. Perhaps one or two of you are interested in calculus. You like math. If you like math, if you really like math, you might want to consider the career field of meteorology because you need math in order to you need skills in math, high level math, in order to map a toroid. All right, that about sums it up. Any questions? No? Okay. Well, if you have a chance to talk to me, email me. You can Skype me as well. Just let me know you're going to Skype. I would appreciate that because I really don't know how it works on my phone. I have it on my phone, but I don't really know how it works. So if you email me, I'll get to it as soon as possible, and then we can do a Skype. Okay, thanks.